Alright, number 9. With this one, we're going to use some properties of exponents to rewrite this function. So we have 1 over, and then on the bottom we have 9 over 4 to the x power. And then you have this minus 2 on the outside. So when you have a fraction and the exponent in the bottom, you can move it up by just changing the sign. So we're going to move the 9 over 4 up to the top this term and change the sign. So we have 9 over 4 to the negative x power. So we kind of got rid of that fraction that was kind of impeding our progress, minus 2. Alright, so 9 over 4 is greater than 1, which means growth. But because of the negative, it's going to flip it, so it's going to look like it's decaying. So this graph is going to look like it's decaying, still crossing at 0, 1. But this minus 2 is going to shift it down 2 units. So it's going to go down 1, down 2. So it's going to cross at negative 1, or sorry, 0, negative 1, because x is still 0, but now it's at negative 1 and not positive 1. So still the same shape, but just flattening out and crossing at negative 1. So that's the shape I'm going to look for. And this top left-hand corner looks good, and that's the only one that's going to cross what we need. And then number 10 is where we switch gears. We want to solve the exponential equation. So what you need is the power table. So if you go power table, this is the one that I like, this image here. And you're going to be rewriting the numbers so that they have the same base. So the base is the big number that you get at the bottom. And then as you rewrite them, you'll be able to solve the problem. So with this example, I have 125. 125 to the x power minus 5 equals 0. First I'm going to add 5 to both sides. It's going to be 125 to the x power equals 5. Alright. Now I want to see if I can write these with the same base. So 5 is a smaller number. Let me see if I can get 125 to be 5. And then if you go to your power table, powers of 5 to the third is equal to 125. So I'm going to rewrite 125 as 5 to the third. And then you still have that x out there. So 5 has an exponent understood as a 1. Here we have to multiply. So we're going to use this property of exponents, power to a power to multiply. So we have 5 to the 3x power is equal to 5 to the first power. Now that you have the same base, you can ignore those and just focus on 3x equals 1. Because the 5s are the same, so they're not affected. So divide by 3. 3 divided by 3 is 1, and then you have x is equal to 1/3. So that's the answer that we're looking for here.